Are you obsessed with all things cosmology? Thanks for tuning in to another Cosmology segment as we get all excited, overwhelmed about how awesome certain things are and how ridiculous other things are. Let's go there. First, let's look at where things are located in the solar system for all you spaced out cosmology nerds. There's where things will be in a week as Venus makes its way around to catch up to the Earth, as the Earth creeps up on Mars, and Mercury fixes to pass both. Now, if you're interested in what's going on in the sky, of course, you'd like to know where the stars are in the daytime, right? Well, you usually can't see them. Check out in-the-sky.org to see what's going on above my head right now. And indeed, the moon is setting. We've also got Jupiter, the Sun, Saturn, Mercury, and Venus, all up there at the same time. It's a cosmic pileup, folks. Where were you when Deneb rose? You know anything about cosmic rays, folks? It's no more images of Deneb? Oh my gosh, it's blasphemy. Do you follow me on Instagram? We put up some exclusive content there, and perhaps check it out, as we like to cover things like screenshots of our interactions online sometimes. Check this one out from this morning. Shout out to Bruce Minas, who says people call him Batman. To which I responded, the first rule of Batman is telling people on the internet that you're Batman. All right, anyway. We are on Instagram, and we do post stuff that you would not otherwise see, perhaps. So perhaps check us out there. And let's talk about smAsho forums. Hey, nice job, by the way, Be Stoic, coming up with this one. The Ohmasa gas experiments. So I'm just going to play a little clip of this.
Okay, so we're going to measure the temperature.
Now, this guy has gone to great lengths to buy a very, very expensive camera that costs 3,500 euros. And he's taken it to this laboratory where he has seen people turning titanium to dust, essentially cutting the titanium with a temperature around 200 degrees C. So here's this guy passing his hand through this white flame toward the beginning. And I'm just going to play you a clip of him showing the temperatures here at the beginning of the video, so that perhaps you check out smashmap.com/forums. And there you can see him passing his hand through the flame out of this white hot looking torch. And somehow the temperatures just don't add up with what you see happening with the metals. So later in the video, he melts a tungsten rod, or I guess doesn't melt it. I don't know. It's not really melted. He's somehow messing with the electrons or something, which has some sort of an effect on the crystal matrix. It does completely different stuff to his hand than it does to titanium, as his hand just gets tingly. So here's an image of it burning titanium, okay, that's a tungsten rod. And you'll eventually see particulate matter coming up off of there, and yet they never measure a temperature over, I believe, 400 C. So it's interesting to say the least, and I've got to contact some bicycle frame builders and tell them about the Ohmasa gas technology, as it could revolutionize the way we make things like titanium alloys, making for some more immortal bikes. Now, I wanted to note to everybody that we have started including a new segment in the daily space weather videos, the proton flux, and also that we're going to put this index of images here, as there are all kinds of images about everything from sunspot cycles to UV data, satellite charging, polar absorption, all kinds of stuff, solar wind stuff. So check that out. We always link the sites we visit below the video in the description. So check out the data yourself. Don't trust me. And shout out to China for building the largest single aperture radio telescope ever built. This thing is so big it has thousands of little motors underneath it to change the shape of the aperture. It's quite amazing. Check out the article here on Science Alert, I suppose, if that's your favorite publication. If not, check it out someplace else. But know about the China absolutely massive FAST telescope. It's the FAST. It stands for, I have no idea. Its nickname is Tianyan, which means eye of the sky or eye of heaven. And it's built in a natural depression, which sounds like it's Robitaille friendly as far as signal to noise ratio. And we're hoping to see some very interesting stuff, including all of that stuff up there. Interferometry, stellar molecules, all of the good stuff we see coming out of radio telescopes. So nicely done, China, with the FAST telescope. We give credit where credit is due. And the surface is made of nearly 4,500 individual panels, and there are more than 2,200 winches on the underside, which can shape the surface, forming a parabola aimed at different parts of the sky, giving it a greater range. And yeah, it's a 300-meter diameter aperture, so that is good stuff. Looking for some fantastic science coming out of there. We'll be keeping an eye on it. Let's talk about the Earth's geomagnetic fields, as it is a mystery as to how these things exist. Nobody really knows how they're generated. And indeed, the ideas behind the theories of their generation are absolutely crazy. So let's get into it. Let me read this series of paragraphs. Previous research indicates the magnetic field is at least 4.2 billion years old and has existed nearly as long as the planet. The inner core, on the other hand, is allegedly a relatively recent addition. It allegedly formed 565 million years ago, according to research from earlier this year. Now, they looked at some zircons, and let's just say it's created some issues regarding the theories of how the Earth's geomagnetic field is generated, as this is a thing that's not understood. So anyway, new theories abound as a result. Check it out. We think that the mechanism is chemical precipitation of magnesium oxide within the Earth. So the condensation of magnesium oxide, maybe solidifying the outer inner core. Who knows what they're really talking about there. We did link to the article. Check out this paragraph. The magnesium oxide was likely dissolved by extreme heat related to the giant impact that formed Earth's moon. As the inside of Earth cooled, magnesium oxide could precipitate out, driving convection and the geodynamo, as it's believed that there's like semi-solid iron in the core, and then there's liquid iron that rotates around it like brushes on a turbine motor, for instance. And seems like an absolutely silly idea, but let's not conjecture today. The researchers believe inner Earth eventually exhausted the magnesium oxide source to the point the magnetic field almost completely collapsed 565 million years ago. And it sounds like some obviation of the fact that the Earth's geomagnetic dynamo is not understood. And perhaps it's some sort of interaction between external and internal forces. Let's keep our minds open on that one. And we did leave links to the article about the orientation of zircon crystals. And let's talk about Galaxy Zoo. Let's go a little farther from home here. Galaxy Zoo's Zooniverse.org's Cosmology project, where we need human beings to classify galaxies, was shut down earlier today. So well done, everybody. You exhausted the data, and more data needed to be updated. In other words, they had to upload more images of distant galaxies for you plebes to classify. So set yourself a login here, as we did. You could get yourself published in a scientific paper. Who knows? It happened last year. And check it out. Let's just go through one real quick. It's got features. It's not really edge on. It could be edge on, but I don't think it's fully edge on. Does it have a bar? I don't see a bar. Is there a spiral arm pattern? Well, certainly not. Is there a bulge? And welcome to the That's What She Said section of the Cosmology segment. There is indeed a central bulge. Let's say that it's moderate. Without getting vulgar. Is the galaxy merging or disturbed? I would say no. And really there aren't any other features there. You could say a ring, perhaps. I don't really see a ring, or a lens or arc, or irregularity, or a dust lane, or overlaps. So it looks like nothing unusual to me. And continue on. So if you want to do some actual cosmology work, again, we need humans to classify these galaxies, as computers can't do it. And speaking of consumers, yeah, consumer price protection, as taxpayer dollars are still searching for dark energy and still not finding any. The first results are back from the dark energy survey, and guess what? They didn't find dark energy. So anyway, we've left links to that article as well as links to the Dark Energy Survey's website. Hopefully that wasn't too choppy. There's that website as well, again linked below the video. Feel free to read about the Dark Energy Survey, exploring 14 alleged years of cosmic history. Now, what they are doing is they are studying voids, which is a good thing. So if you don't understand about voids, such as the local void, the Boötes void, the Taurus void, there are some giant places in space where there isn't a lot of stuff, which are just as interesting as the places where there is a lot of stuff. So perhaps read about it if you like. Let's talk about supernovae. Are you concerned about supernovae? Are you really worried that a supernova could happen at any moment and beam you up like Scotty? Well, if you want to study the spectra, there has been a massive data dump of supernoval spectra. It's called the BeastNet project, and it's releasing the spectra of more than 200 supernovae in the Type 1a category. And we won't get in depth in any of this, but over 600 total spectra of over 200 total objects, and all the links shall be below the video. Talk about NGC-1022, which is in the news today. Perhaps read all about this 66 million light-year away galaxy located in the constellation of Cetus, discovered in September of 1765 by William Herschel. There's an image of it, and it's what we call a barred spiral, and really you need a spectral view of it to really see this very well. Here's a more zoomed in view, folks. And if you view this in X-ray, the bar is super obvious. And here's an article on SciTech Daily about it. It's, again, NGC-1022. Let's talk about the spectra, really the transient X-ray bursts from Cygnus X3, which has just descended into a very quiescent state there. So you see it's a very low number of transients. It looks like it's actually going back up the scale here. As you see, the zero line is all the way at the bottom. And Cygnus X3 always goes into a quiescent state before it goes into a high energy state. So that's something to keep an eye on throughout the day, month, year, decade, and century. Cygnus X3. And you can look for it yourself at the Neil Gorell Swift Observatory. Just type Control F and type in CYG space X-3. And it'll take you right there. If you're more interested in Cygnus X1, well, it's there too. If you're interested in Sagittarius A star, it's there as well. Don't type in the star though, it's just A star on this one for some reason. Otherwise known as the catchy title of CXOGC J17450.0-290027. There are the transients from Sagittarius A star. And we just saw a bunch of dense transients come out of it. Those are X-rays, folks. And again, don't forget to follow Cygnus, massive X-ray binary, located at a disputed distance. There it is on Aladdin. I would note that it's got some interesting jets coming out of the far side of it, which I think is actually showing here. It's quite an interesting object, and the ancients agreed. If you follow all that ancient stuff, again, check out smashomash.com/forum. There's a whole thread associated with Cygnus X3. In fact, we've even put it in the most, as Cygnus X3 is the most likely consistent source of cosmic rays besides the sun that there is. By the way, if you enjoy the rest of the content, please don't forget to like and subscribe on YouTube, and share on the rest of your social media, as who knows, one of these years, with hundreds and hundreds of space weather videos, we could actually reach 1,500 subscribers. Oh my goodness! And we've been seeing a little bit of magnetic activity kicking off on the local yellow dwarf today. Here is the latest from the colorized magnetogram. At least 3 areas of a little bit of magnetic complexity happening there north of the equator. Not a lot happening in the south. And there are your time and date stamps. Pause it if you need to. Here's 48 hours of the local yellow dwarf here in 171 angstroms. My personal favorite wavelength. And we see a little bit of activity kicking off there in the northeast. Right about here underneath my pointer, if you can see that there, folks, right in that area. A little bit of plasma bumping around in there. And a small filament discharge in the southeast. And it's a bonus feature, the 131 angstroms view also. 48-hour video there. No sunspots, pretty weak solar activity. Thanks for tuning in, folks. We hope you enjoyed the cosmology segment. More videos coming, and lots throughout the year. Keep on staring at that sun. Smash signing off.